All right, so this is the second session of the surfacing class here at the user group. For those of you who weren't with us the first time, I'm Dale Slotman. I'm the lead mechanical engineer at Copes Incorporated. Feel free to email me after the presentation if you have any further questions or comments, or if you have any spam you want to get rid of. Maybe just a quick overview in where we were at when we left. So a couple key points that I really stress with my engineers: knowing what you want to design before you begin. Having an idea what you want your part to look like is critical, because it affects what you need to do to get there. And then the second point, doing most of your surface work outside of your final part. That's what we were just talking about. It's less parametric. I understand that if you have an extend surface and you find out that you need to extend it further, you're not going to be able to do that. But it's way less likely to explode on you because of a rebuild, and way, way less horsepower needed on your computer. So, we can look at that in just a second. But then also knowing what level of criticality is needed on your surfaces, that has to do with knowing what you want to design before you begin as well. We started a part in the last session that we made some design decisions on. We decided what we wanted our start plane to be. We didn't want it to be just straight to plane one of our part. We wanted it to be at an angle because of the draw of the part. So that's something that you need to make that decision really up front. You can't wait to make that decision. Second thing, you want to know what your end or perimeter conditions are. By that I mean it's pretty critical that up front you make the decision. Let me go back to just my customer part here. So I made a decision that I didn't care about extending out past the perimeter of the part. I was just going to nest a little bit inset. Now, if I wanted to extend that out for run out for whatever, then I would need to extend this face out in my surfacing work. If I wanted to actually follow this contour and do more of a concave nest, a pocketed nest, then that would also be something you'd want to know up front, because it's going to impact what surfaces you pull out to begin with. So for my part, I pulled out just the flange surfaces. I just pulled out these surfaces and then extruded up to them. And then we just did a little demonstration of, okay, well, if I want to extend those faces out and then pull that surface back in so that the surface work is not part of the part, you can do that. Also, if you guys have questions or comments, I have more treats to give out. So remind me to throw these out before like 5 minutes until it's done, like I did last time. So, all right. So some more surfacing work that needs to be done on this part in particular involves all this middle section. So if we go back to our customer part here, we decided in the first section that we want to support these faces of the part, but we don't really care about these faces. So I'm not going to pull in all of these faces to nest to. I'm only going to pull in these faces, but I need to extrude up to them. And I don't want to just like extrude a boss up to this one, extrude a boss up to this one, extrude a boss up to that one. I just want to have one boss that extrudes up to, basically what would be this face if it was continuous. So that means I need to make a continuous face on here. So I'm going to take these surfaces and I'm going to rip them out of the part. I'm going to do a save as And again, I'm selecting multiple faces that are touching each other, so I'm going to take IGES so that they heal together instead of this being an individual body and this being an individual body and that, yeah, and all of that. That's an edge. So it's important when you're selecting stuff to have dynamic highlight on and also edges shown. Those are key things when you're working with surfaces. Helps you know what you're going to select. Do you guys know what that means, everybody? Okay, sweet. Yeah, so those faces, I've already got that saved off, so I'm just going to open it up. Top surfaces.IGES.
Can you repeat that IGES thing for people that weren't here earlier?
Yeah, so when you save off faces as an IGES, it will knit them together. So like these two faces are not separate bodies. Whereas if I would have done this and saved it off as a parasolid, even though they're touching each other, I just want those two faces just as an example. I'm going to open up that parasolid and we'll see that those are two separate bodies at this point, which usually you want them actually knit together. Now you could just go through and knit them together. That would work, but it's an extra step. So you may as well just save it as an IGES. And that will also heal things that aren't necessarily separate bodies, but like we saw in that extend faces example of this, when we initially extended these faces, these two had a blue line in between them, so it will knit stuff like that together too. So IGES is a useful tool for knitting surfaces together. Just save it as an IGES, pull it back in, and it'll knit stuff together. So even stuff that knit will not do, even if you make your range up to like 5 inches or whatever, there's things that SOLIDWORKS cannot knit, but IGES will somehow do it where knit can't. So I don't know.
Trim them and stuff like that.
What does it trim?
Trim them nice, because I know when you extend surfaces, sometimes you get them.
Oh yeah.
Glossing and stuff like that.
Yep. It sometimes goes ugly on you. So yeah, I typically tend not to use that as a first resort, but it's a good last resort. So yeah. Let's see. So I've got my top surfaces here. Basically, I want to make a continuous surface out of this that I can actually utilize for a single extrude. So I need to extend out some faces. I need to go in between faces. So I think this is a good time for me to talk about, I've got 3 main ways of extending out faces. And my preferred method is untrimmed surface. So you can either untrim edges, and that will make that squared off, or you could untrim an entire body, or an entire face, sorry. The reason I prefer this is it gives a pretty clean rectangle here. It's all one continuous face. It's not making an extra face for you. It's just the cleanest. Now, it's also kind of the least likely to actually solve. So these are nice clean ones that will solve. So like here I can untrim this surface and it makes a nice rectangle for me. Like this I would probably just untrim these edges here to get that guy, and then you can just untrim that, and then you want to merge with original too. If you don't take merge with original, it just makes a new face there, and then you got this weird double face thing going on. My second favorite extender is extend surface. I mean, that's kind of, obvious. Extend surface extends the surface. But the linear type makes a new face. So you're stuck with another face, which isn't always ideal. It's usually ideal to have just one face. The same surface, while it doesn't create a new face, if there's curvature to the part, it wants to continue that curvature, and it will sometimes just like go crazy off into space, and it's not what you really want. So extend surface has its limitations. Another one that I like is ruled surface. So ruled surface isn't going to be the best option here because my surfaces, the surface that I want to extend is not at all like XYZ parallel. It's just got a lot of curvature to it. So you can do tangent to surface, but that's essentially doing the same thing as just extend out linear. So the thing about ruled surface, if you need to extend out a face in, let's say I just want to go in the Z direction, I can just give it a Z dimension, and I can extend that, 1 inch up. And ruled surface almost always solves. Like where extend surface doesn't solve a lot of times, ruled surface, I rarely find that it fails on me. So this is especially helpful when you have a die draw situation. So if you've got to create surfaces that are perpendicular to your, or I guess parallel to your die draw, ruled surface is a good way to go. So let's maybe just take an example of that a second. So let's say that, for instance, I've got this part here, and I wanted to actually utilize a nest that's going to come straight from above instead of coming at an angle. I'm going to have some die draw issues with these bosses. So I'm just going to take these faces here, and I'm going to save these off as an IGES and bring them back in so that I can work with those surfaces. Once it comes in. So now that it comes in, I want to do a split line on these surfaces so that I can find where it's tangent to my die draw. So my die draw is in the straight Z direction in this case. So yeah, features, curves, split line. So I'm going to take it, I'm going to split. We're going to do a silhouette of plane 1. So the plane that is my draw plane of these faces, and it's going to split the face where it's tangent to the normal. You can see, whoa, it's very, whoa, that's messed up. Maybe I should have tested this first. Okay, well, I'm going to delete that stuff anyway, I think. So if I go before my split line, okay, we can see the split line it creates is right here. So I want everything below this to go away, because that's just going to be a die draw situation. So I'm going to delete those faces, delete that one, and delete this one just to give me a separate body there. Okay, so now I can take this edge and I can do a ruled surface in straight Z. Except I want it negative Z. We'll just go 2 inches. On both of those. So you can see it's creating that straight cliff down. Oh, it's not going to knit it, so say, okay, you don't have to knit. That's fine. Okay, so now I've got that. I kind of want to span between this gap though, so I'm going to take, and I got two options here to span this gap. I can either do a lofted surface in between them or a boundary surface in between them. It's kind of 6 of one, half dozen of the other in this situation. So I'm going to take here. Are you guys familiar with the selection manager for picking edges? This is a really useful tool when you're doing either a loft or a boundary surface or a sweep. If you want to take multiple edges and use them as a single entity, so like on a lofted surface, I could do this. Do a single loft here, a single loft there, and a single loft here. Or I could take and loft and do selection manager and pick these 3 edges. And now boom, it's one entity. And now take selection manager, take that one, and this one as a separate, as a single entity, and boom, it's one loft. So selection manager is really, really nice when you're picking edges and like doing stuff with them. So yeah, so I would use this type of geometry to nest this part if it was a die draw situation. All right. Boy, I skipped around there a little bit. Went off track. What we were doing is making this all one single unit. So I don't really care at this point about extending that face necessarily, because what I want to do is I actually want to take these, you know, and actually kind of bridge the gaps on all of them. So that's going to take a while. So I did it already. So I'm going to open up that part.
I was really hoping you could say, oh, pick all these surfaces.
Oh, that would be nice. I don't know of a function that does that.
Jeez, that's what I was hoping for. I was going to throw you a candy bar.
Oh, yeah, candy. Did anybody else participate? I forget. Candy? You need one in the back. Ow. That was perfect shot, right to the mouth.
Hey Dale, have you ever done like a lofted surface from like thinking if you delete that loft you just did? Like
Yep.
where you just pick like the edge of each of the short sides of the rectangles as you're creating your loft, and just like create one loft. Like go into your loft, create a loft.
Yep.
Now start on the short side, but on the other side of it, the other end of it.
Like this?
Yeah.
Go from here.
Well, no, but then just keep selecting them and it'll build like one.
Oh, yeah, you could do that. Yep. Okay, so do this sort of action
I don't know if it's better.
and make it one loft. The thing that I don't like about that is you lose
You're
the
creating-
actual customer data
You're creating
in these
geometry.
areas. Where here it's fairly flat, it'd probably be fine. But if this part had like a lot of curvature to it and a lot of like dipsy-doos and stuff,
That's
Yeah.
the most difficult thing, is retaining
Actual-
line depth.
Yeah, the face of the
Right.
Because everything's going to be, that's, I
I bet
don't
you'd be
do
surprised
it,
how close
like
they are.
everything I do is going to be.
and on
just-
this part, yeah, it's going to be dang
Yeah.
close. A couple thousandths at most off,
Because then
probably.
you could have one surface or one lofted surface that goes across the one whole row there, and then you can extend that lofted surface.
Yeah.
And
So, yeah, I actually went through the brute force of actually doing boundary surfaces or lofted surfaces in between all of them. So, I don't remember which one it is though. Let's see. It's probably 1. Pick piece nest 1. Nope. Ah, here it is. So, yeah, you can see I did a lot of boundary surfaces and lofts. So, here is a good example of where there's a difference between like the loft and the boundary surface. The loft here has more of like a sweep, or sorry, boundary surface. Wow, maybe it's not different. I was going to say the boundary surface wouldn't have been as swept, but that's actually is a boundary surface. So I want to see what a loft looks like now in that area. So I'm going to selection manager this. Okay, And then that one. Okay, yeah, so Loft is actually more squared off. It doesn't do the sweep. So, yeah. Slightly different geometry, but...
But now it does if you select some tangencies and things like that, right?
Oh, yeah, maybe. Let's see if I select tangencies. That's a good point. I did select tangencies on these areas because
Or
it's
if you
not...
grab the curve on the side.
Oh, yeah, look at
Yeah,
that.
that's a guy curve.
Yeah. So it's a slightly different result in this area, but for me, I care about this surface and about that surface. Those are my customer surfaces, so I don't really care what's going on in between them. I do like that they're tangent, but other than that...
Quick question.
Yeah.
So you've got those, you copied those surfaces, the little top parts of those surfaces.
Yep.
So what the smart thing to be to, since those are curved around, to extend just that surface away from the part a bit before extending and joining so that you make sure that you don't have any weird join points right at that surface.
Yeah, probably. Yep, that's a good point.
So extend them first. And then
Yeah. Or just, I mean, even just doing an untrim on it first would probably extend it out a little bit, but maybe not. Oh, this one I actually did do an untrim on first, I think. Yeah, that's a good point. It's probably a good idea to extend them first. Okay, so now that I've got these surfaces, it would be kind of a mess if I left this all in my final part. So I'm going to take this and make an IGES out of it so that I can so that I can extrude up to that. I'll just open up my final part here a second and we'll see. So I've got these two surfaces in there, and you can see I actually extended out the outside boundary of those as well, which kind of was a mess in a couple areas, but doesn't really matter that it extended further before I made the IGES for this one. So I just did extend surface on all the outer edges of that. At that point, yeah, basically I just make a sketch here. Let me go back. So this is what I had before for what I extruded up to that perimeter flange. So I took and I just did convert entities on some of these interior edges and then put a couple lines in there to close off the sketch, and then just extruded that up to that body there, and then did the same thing there and there. So at this point I've got good contact on all the tops of my surfaces. I got good contact on the flange. I'm pretty set. So I'm going to take and fillet all of these edges, and some of these were harder to fillet than others. So you can see this one here has a variable fillet instead of a normal fillet, because if I go and I start the fillet tool, you can see it doesn't want to make this jump here. It doesn't like it even if I pick multiple edges. So one thing that we found is that variable radius fillet does a good job where other fillets can't solve. So I'm going to select tangent C, which is really only important when you're doing variable radius, because what it's going to happen is I'm going to say I want to set all of these unassigned points. There's a ton of unassigned points because there's a lot of little edges in there. And I'm going to set them all. And boom, now it'll solve. Why a variable radius will solve in this case and another one won't? The only reason that we've kind of figured out is that the variable radius doesn't care as much about points where you haven't defined it. So it's defined, at this point and at this point, but halfway in between it can vary a little bit, I guess. So yeah, variable radius will solve when others won't. Now, variable radius isn't a magic bullet. It will sometimes fail as well. So keep that in mind.
Have you ever gotten the fillet expert to ever work?
Never.
I haven't either.
Even on like actual, just like,
Simple part.
yeah, simple, squared off, no surfaces. Yeah.
I've never had it work.
Nope. Me either. I actually had one part one time where it's like, oh, I think this one might be the one case where it'll work, but nope, it didn't work. All right. Yeah, and then after that on this part, basically all I do is add in some like in context features for, oh yeah, this one aired out because I made that new one.
Facebook works sometimes in some areas, but it alters geometry. So.
Yeah, and especially in something like this where you've got a ton of faces, it's hardly worth picking all the faces to find out whether it's going to work.
In special areas like corners and that where it's everything's transition.
Yep, yeah. No, that's a good point. Yep, face fillet will sometimes do it where others won't. Let's see, any other fillet options we should talk about? Tangent propagation. So let me scroll back before I filleted. Sometimes too, like, okay, I've got this whole outer edge that's tangent. If this one particular edge that I have highlighted is an issue, I can just turn off tangent propagation and like take, oh, I'm gonna go back to normal fillet here. Take only a couple of the edges, and now it's gonna make a liar out of me because it's not gonna solve it all. Okay, so here, I can solve this, and boom, okay, I got some of those fillets done. All right, now I'm gonna go on and, okay, we're gonna go on and see how far we can get. Okay, boom, it's good. I'll break it up into sections like that to make the fillets solve sometimes. So.
Sometimes, like on your inner surface, say you had two surfaces close to each other, and you want to put a fillet in the bottom, where it would actually
Oh yeah.
eliminate that one surface that's close to that thing.
Yeah, that's a key point. Yeah. So like here, if I want to make a fillet that's bigger than 0.263.
Right.
So here, if I want to have like a 0.3, it may or may not solve. Yeah, it's not going to solve because you can see it's got some junk going on there. Oops, actually. So even though I'm getting a preview, I doubt that's going to solve. Yeah. That's a case, I think face fillet might work here. If I take this face. Whoa, and it didn't even, that's kind of weird, because it didn't even go to this face. But, so I've had it before where if I tell it, okay, it's okay to go into this face, basically, by using face fillet, that will help it to solve.
At least you can cut it with CNC.
Right, exactly.
It's all like they're
Yep. So, I mean, even filleting these edges is an option. It's a design decision that I made. I could have squared off these faces, actually made a mill cut on this edge. You know, we do that quite often, that we'll just mill out a flat area there that they can see and see.
Recess there, yeah.
Exactly. Yep, if I don't care about that corner geometry, I'll just clear it out with a squared off end mill. So that would be a separate cut feature that would do that. But this one has enough angle to it that's going to be kind of junky in this area. Okay. I think that's all I really had on this particular part for surfacing. Let me go back to my PowerPoint and see if I missed anything. Okay, so we talked about split line and ruled surface. Those two work together very well. Ways to extend a face. I like untrimmed best, extend, and then ruled surface. We didn't do much delete face. I guess we did look at it a little bit. One thing that I've found is you sometimes, I'm trying to think of a situation where I've used this, but sometimes it's nice to be able to delete a face and patch. I think it's more when I've got basically geometry that I want to modify. So like let's say I don't want this hole anymore. Let's say this is just a imported body and it's not something that I actually designed. I could delete these faces and patch them. And it's going to take that hole out. And it patches the top and it patches the bottom and makes it just like one solid. So that's kind of a handy feature sometimes. Delete hole. So, that's one thing that I didn't show on these top surfaces. One of them had a hole in it. Ah, yes. Yep, the 2 and 4-way locators on this part. So I just delete that hole using the delete hole command. So to get that, you pick an edge and you hit the delete button. Maybe there's edge delete and delete hole. If you delete feature, it's going to delete that whole body. But if you delete hole, it gets rid of it. Now delete hole works almost all the time when it's on one face. You can see this hole doesn't break over into another face. If it broke into the second face, 50-50 whether it's going to work. If it breaks onto a third face, I don't think I've ever had it patch 3 faces with a single delete hole. So, is what it is. Untrim will also take care of that if you did it like that and merge with the original. Failed to merge, of course. Let me, I could probably just untrim the, nope, can't do that either.
Check that you're untrimmed and just do internal edges.
Sorry, untrim and then
Select the feature.
Sele-
No, the solid. Okay. That right there. No,
Oh,
click
internal edges. Oh, boom, look at that. Awesome. Can it merge too? Ah, sweet. Huh. I don't think I ever noticed that particular thing before.
Will it work on triangle shapes too?
It'll work on any hole. Yeah.
I've had an issue with it trying to fill. Okay.
If it's only breaking a single face, it's almost sure to work, in my experience. Even if it's like some bizarro hole. All you have to do is select one edge and do delete hole. Or were you saying untrim surface?
The untrimmed surface.
I think that would probably work too. Yeah. Now I think both untrimmed surface will actually work if it's over 2 faces, but quite often you end up with a blue line, a non-joined edge in the center of it. So be aware of that. You might have to either knit it or round trip it as an IGES. So okay, so boundary surface, we talked about selection manager, variable radius fillets. Oh yeah, and then direct editing, move face and move body. I don't use move face a lot while I'm designing a part, but I'll often have it after a part is already built that they say, oh, we actually want a little bit more clearance on this. We want 1 millimeter more clearance on this nest. It's like, really? I got to go back and like redo my surfaces or redo all of these sketches to move them all out 1 millimeter. It's like, well, the easiest thing to do is sometimes just to like move the face. So let me go to direct editing, move face. So let's say I need to bump this wall out 1 millimeter. I'm going to do a translate in Y.
Translate or would you offset?
I would translate in this case because I have this curved face too, that if I offset, it's going to want to actually bump that out. I want to just shift it over. If I wanted to actually have this face bump out and this face bump out, then I do offset. So I don't know, we could try both ways. Although I think offset's likely to fail because of these fillets here. So I'm actually just going to do translate first to see if it works. I'm going to take all of these faces here, because I want to move all of these guys over by 1 millimeter. And I'm hoping it works. I didn't test this. Why 1 millimeter? Do it. Do it. It's not going to work. Yeah, it didn't give me a preview, so it's not going to work. No dice. Okay. Well.
If you don't take your curves in the corner, let's see.
Yeah. Yeah, I think this is going to fail too. This is a bad example of move face. Sorry.
Yeah, this is what we have to do.
I know. It's not your ready-made SolidWorks what's new example.
I've had it where I frequently had to delete the radiuses and then move the face and add radiuses back in.
Yeah, if I go before the fillets, it'll probably do it. That's a good point. So if I just take this face and move face by 1 millimeter, yeah, that'll solve. So, yep, good call. And then since all of my edges are the same, my fillets still update. I think this one was aired out already before that. So, all right. Boy, I'm at the end of my presentation here. I got 20 more minutes. Replace face. Oh yeah, replace face. Oh, good call. All right. So replace face. Let me pull open my final nest again. Where did that guy go? Do I not have it anymore? There it is. Okay. So let's say I got some new customer data, and this one might be a little too complex to do a full replace face on, but I'm just gonna pretend. I was gonna say that like these faces here. Yeah, that's not gonna work. Basically, replace face is you can take a surface and you can pick faces and say, just replace those faces with that surface. So, here, I know what I'll do. Okay.
Could you do that in your outside keyboard fill-in patchwork quilt?
Like this?
No, back when the surface that you cut that internal keyboard where you did that.
Or
No,
this one?
Go down one. I think it was 7 down.
This one.
That surface, could you replace that with a surface?
You could, yes. Yeah. Let's.
I mean, so that it wasn't such a quilt looking thing.
Yep. Oh, I see. Okay, yeah. If we wanted to do that, so I'm gonna take this face here, and I'm gonna just make myself a new surface to say, okay, I want to replace it with this surface. So I'm going to do a 0 offset and then take that, untrim it so it gets some square edges. Oh, take that face. Okay, I got to hide my body here a second. All right, take this guy, untrim it, all edges. Oh, I wanted it to merge. Shoot. Okay, and I'm going to take my outer edges, select open, not open tangency, open loop. Just select all the outer edges. And I'm going to extend. I'm hoping this extends by 5 inches. Same surface. Ooh,
Yes.
yes.
That's what I
I
want.
love that. Ooh, even better. Yeah, let's continue. I don't think that's going to be a good idea. Come on, SolidWorks. Oh, it failed. Okay. Oh, even better, it crashed. All right.
Have you seen this before? Yes.
One of my guys, he kept on putting in, if anybody reads this, email me at blah 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 blah. And after like 6 months of not getting any emails in response, he's just started pasting full like acts of Shakespeare, like Act 1, Scene 5 of Romeo and Juliet. Pastes it in there as his comments. So he's still waiting to hear back, but. So I was going to replace all of those faces with a new surface. Ooh, I got a better idea. All right, I think I know how I can make this work. Okay. So I need just the nest.
Either just a nest, or if you could do it in your surface part that you were working externally with. So when you did the cut, you cut.
Okay, so I need that surface. Hide that. Okay, I'm going to take these edges. And just as an example, I'm going to take a small section of them.
If you work in small sections, then you can break it down to like 4 plots that say instead of trying to do all as one, and then you can take those 4 and you do them, put them and make them all one. That'd be
So here I'm just going to straight up do a fill surface in there so that it's just one surface. So now I've got a filled surface that I can replace those faces with this single surface. This single surface could also be different. Like if I fill this surface and I go to, I don't know, something to make sure that it actually
How can you check this?
It's different.
Data?
I wouldn't do it in this case because it isn't going to customer data. I'm just showing it as an example. Okay, so I actually only have 2 faces in there that I can replace, but I'm going to hide this so that I can pick the faces. So I'm going to replace those faces with that surface. Oh, and it still takes 2 faces. It should have been 1 face. Ah! Stupid SolidWorks. All right, well,
See, that's what I ran into, and that's what I asked.
so I have had replace face work for me. It's more for if, like, okay, on a simpler geometry, if I just have, like, a boss coming up to 1 face, if I want to replace that with a face that's, like, higher or lower or different geometry, and there's not fillets on it or anything, I can get it to replace sometimes. So
They never use it.
I do use it. It's just maybe once a month, you know?
I've never successfully used it, so that's the reason I was hoping.
It's got to be the right situation. That's the thing. It's like if you have anything where there's like a boatload of faces like this, it just isn't going to work.
Like open the surface that you created for your.
So like,
Could you pick all those, like that one body there, you pick all of those and say, make that, could you make that one surface
okay, let me.
with that through a replace face?
I don't think it's going to work on just surface geometry.
I don't think
The-
that it'll work if you're dealing with the same surface as what you were dealing with
So
That's
for example, if you were to go and create another surface in your other sketch that was like a dome up above it, you could do replace face with the one surface with the other, which would create that as a dome. So if you were to go back into your main part and then just simply create a whole new surface above the bottom, in essence, I think you can do is replace face at that point.
I clicked on new part and it's actually I'm VPN'd into Copes, so now it's trying to get our templates from our network drive. So that's what's going on here. Okay.
If you wanted to do what you're doing there, you definitely want to do it before you start putting all these fills in.
Yeah, that's definitely true. Okay, so I'm just gonna do a simple replace face here. So I need a planar surface. Nope, sorry. I need a plane that is 2 degrees off. And then I'm just going to take on this plane, draw a sketch, planar surface. Okay, so I'm going to replace face. I'm going to replace this face with that surface. Boom. That's about the simplest you can get, but it does work when it's somewhat simple like that. And it's like, okay, I've got this face or these two faces, and I've got this new thing that I want it to match. You can get it to work sometimes. All right. Any other questions or thoughts? We got 10 minutes left, and
Show me how you fill surfaces.
filleting surfaces. So, like inside of a surface body.
Like, so you get a flat surface that you want to nest on, but then the sidewalls you got offset with maybe 2 or 3 thousandths clearance, so you can get it out of your nest.
Yep.
I still want to fill it in those corners that are offset. You can extend the surfaces out until it's a nice neat shape like square, but I can really successfully fill it to them unless all my edges are nice and clean.
You're saying fill
Yeah.
as it fill with your surfaces before you like extrude up to them or cut
Yes.
or whatever.
Oh, okay.
That's
So,
probably why it's
so not filleting afterwards like I did.
Fill it the surfaces, yes.
That's another reason why you would maybe use like extrudes versus cuts. Maybe.
I
In
use a lot of
surfaces,
cuts
if you got surfaces that are in there, you have to extend them beyond, trim it back, then make it all one body, and then your trim will trim and you can put a fillet in. on the
If you've got
surface.
all nice clean edges and they all meet, I'm just hoping.
So if I had these surfaces here,
Will it be a variable fillet? Or will it be-
If it worked, try it.
I've never had
so saving this off as an IGES, bringing it back in so it's just the surface I selected.
Okay, now see that.
So I want to
Okay, that's
extend
all
these
right.
out, right? Where's my extend? There it is. Nope, that's extrude. God, different monitor. Alright, and I want to extend these out. Okay, so now I'm going to trim these up. Because I want to trim both of them, I'm going to use mutual. Take both of them bodies. And I'm going to say that I want to keep that section and that section. No, that's not what I told it. This section.
Hides it.
Oh, yeah, that's right. Yeah, it's hiding. Yeah, okay. That's a good point. It's only showing what's left. Okay, so I've got this as one single surface body now. And so now I can fillet it. You can't fillet it unless it's a single surface body. If these were two surface bodies, it's not going to let that happen. So you're saying to put a fillet in here. Now,
Or say if I wanted to fill it bigger than that, you know, first tangent or something like that.
right.
That's the kind of the way you've done it, where you've trimmed it all the bodies.
Okay, your radius, or your variable radius.
There it worked.
You just select them all. That's weird.
Yeah. So if I did select tangent C and then go into fillet, the variable radius, you know, it's more likely to work. I don't fillet surfaces much. I usually wait until it's in the solid part. I've had better success filleting solids than surfaces. So
There's been situations where that's the only way I've been able to get it to work, is to trim everything off so it's a nice sharp clean edge to one another, and sometimes that takes a while to even get to that point.
So if I wanted to do like a 0.3 there, yeah, that'll solve. That's surprising. Yeah, I honestly don't fillet surfaces much because I've had better luck waiting until it's in the solid and then filleting it. But it does mean that my final part has extra work in it. It has those fillets in it that SolidWorks might thinks that it needs to rebuild. So
and usually when I run into it, it's something that's maybe a sweep or a radius. It's some weird thing, and there was a cutout in it, and so now I'm trying to fill in wherever that cutout was, and you know, you're trying to patch all that weird geometry.
right. Yeah, a lot of it is just like knowing what tools you have in your toolbox here and just going at it with a sledgehammer and seeing what will work.
Can we do a variable swept surface?
A variable swept
Just
surface.
Swept, so it shows a swept surface.
So if I wanted to sweep a
Yeah,
surface,
swept cut, basically. I'm thinking, I guess, more kind of like an off sweep.
right. I honestly don't use swept surface much. Yeah, because sweeping is more like creating geometry that I don't necessarily want to do. I want to use my customer's geometry. I'm trying to think of a way to even show that. Yeah. Yeah, I use mostly lofts and boundary surface. Yeah, sorry.
No, that's okay. I've never used it, so.
Right. I'm trying to think of anything else that.
Is that part actual solid now, or full? If you section that thing, is it a big piece or is it just hollow?
Yeah, no, this is solid. And so it's solid geometry because it's boss extrudes, you know, going up to those surfaces. So. Oh, I'll show something here.
Up on the top of the tree that shows the word.
Yeah.
It's got one solid.
Yep, one solid, and then there's 4 hidden surfaces.
Maybe show some fun with Loft surfaces.
One thing that I find in this, where is that? I had a headliner in here.
Top row.
Ah, there it is. Okay, so if I need to make a lot of nests or multiple nests that are utilizing the same surfaces, I will take these surfaces. I'll basically make sure I've got all the surfaces that I need for all of the nests, and bring them and make one nest. So select your faces, open edges. So I want to be about 44 inches up. So I'll take and make one nest, go up to surface, do my fillets. Whoa, I don't know what that just picked. I'll even put my holes in, and then I will make an assembly. Oh yeah, I'm gonna have to save that. Put it in an assembly, and then just do a save as to this part, edit the base sketch to shift it over to be my new nest, do a save as to that, edit the base sketch, shift it over to be my new part. So basically getting one nest done and then utilizing that, the geometry and the work that I've done, into multiple parts. So
Now, you said that you would actually put the holes in there as well,
yeah,
time saver, but would you have to edit the hole positions as well for each one so they're idiot proof?
well, it depends on how you put your holes in. You know, if you're dimensioning them off from the edges will move with it. So if you're dimensioning them off the origin, that would be a problem. Yeah. No. Okay. Yeah. We're at our time limit, so I think you guys get the idea. Any last questions or comments?
How do you do like a double check to, you know, if you've made all these changes, and do you kind of overlay the customer data over it to kind
Yeah.
of make your,
So in an assembly, we have both our parts and our customer data, and because they both are what we call InCar, to where the origin, where the origins match, and we'll set them in assembly where they match the origin of the assembly as well.
okay.
And so we know that this part's in the correct location. We actually fix those components in place. Those are the only times we fix a component, is when its origin is the same as the origin of the assembly. So that's just kind of our cue to know that it's InCar. And at that point, you can just do something like select other on the back face and take a look at, okay, yep, all of these surfaces line up. So we're good to go.
Oh, okay.
And to see, okay, well, there's no interferences in this part either. So that's just a quick check.
Can you do like evaluate, kind of see how much interference or anything like that? Or
There
There's
is
no
like
visual.
interference detection.
If they're solids,
yeah.
Yeah.
customers' parts, it's all surfaces, then it doesn't matter.
Oh,
Yep.
okay.
Yeah, that's true.
What you can do is you can run a cut, and then the cut will, as you go through it, it'll show you where,
Okay.
you know, they have different color.
Like do a section, you're saying?
Oh, okay.
Yeah, and if you look at the two surfaces, you can see the differences between the two. They'll be different colors.
Okay.
Yep.
Do you have any rule of thumb, like when you're creating your nest, a good best practices for doing your orientation of your data, of your start planes?
Typically we go to the draw of the part. Now sometimes we have multiple parts that we're trying to all go off from a common fixture that have different draw angles. So there we just kind of cheat to be kind of in between. So this one, I think technically it was like 34.2 degrees or something that the draw angle was. And I could see that on like the locator features. For instance, we're cut, straight to a draw. So I just cheated it to 35. Called it good.
I mean, I'm usually looking for like, the flat surfaces that those datum holes for
Right.
two ways are in. and stuff like that to try and pick off of.
Right, and that's what we would typically do too. And especially if like this face was flat, and it may even be, I didn't check it, but
At least perpendicular to the hole.
nope, it's not flat.
It's not even
But
flat.
if it were flat, we could just like use this to get our start plane. Just take a plane off from that by 2 inches and make that our start plane. Yep.
Because, I mean, I understand you do the InCar part, and I do a lot of this too, but I draw my block center of basically my fixture.
Okay.
And if I do get a new customer part, I put that new customer part in, again, with the origin.
Yep.
So at the InCar position. But I've also got new data later, the third or fourth rendition, and, the origin's off in space, and I never even put new data when they actually.
Oh. Okay.
So then you're really kind of.
Yeah, at that point, all bets are off. Do any of you guys take your surfaces and make them reference, or what's the word I'm looking for? Just do like an offset face from an assembly.
I do that all the time.
Yeah.
I'll make my block around my customer data,
Yep.
and I'll edit my nest block and say offset that surface.
So do
offset those surfaces,
edit part and then
then edit part. And
offset
do my-
surface to
then do my
0.
cuts there. You know, like that, your keyboard surface that you wanted to actually set on,
Yep.
I'd offset that 0, but then the clearance on the side, maybe 2 or 3 thousandths on the side, I'd offset those surfaces.
Yep.
Then I go to my part, do all my extends and patches and stuff, and then cut at the part level.
Right.
But
So.
you said you may end up with a whole tree of stuff there.
Right. Yeah, and if you do that, then it's going to be way less advantageous to do your surface work outside of the part, because you're going to lose, if this part shifts at all, then all bets are off as to where your data actually landed. So, yeah. Different ways of doing stuff. I got more treats left, so feel free to come up and grab some. Got a couple of Reese's trees and Snicker trees. Thank you guys so much.
Thanks, Dale.